All right, we are live again. Okay, stream is good, audio is good, everything looks fine, so let's get started. In my previous stream, I've been talking about strokes drawing, and last night I finally got everything working and pushed the performance to the limits by creating multiple threads and also by eliminating dead times where the Q mutex got locked while presenting the frame. Presentation is a blocking call, so it will wait until the screen refresh is ready for swapping the buffers, and that can take up to 16 milliseconds if the frame rate aims to 60 frames per second, and that is a lot of wasted time. So what I did is that I pretty much compute, so this thread is just doing the presentation, so that gets called that's the function that gets called from the main render thread, which does pretty much just that. So it renders the frame and keeps looping over and over again, computing the time difference within from one frame to another. And so I even think this is computed wrong, but should not return from it since we are just sleeping and putting the weight on the thread on wait. Oh, someone is calling. Oh, okay. Back to do some useful work. And so what was I talking about? The rendering the frame, yeah, just sleeping for the amount of time that already elapsed. I mean the period of the frame, which is 16 milliseconds, and the amount of time that already elapsed since the last come back to this function here, minus 10% of the period, just to be safe and not hit that. If we basically get a little bit late, we are then delayed to the next vsync, which we don't want, but we can instead wait a little bit more, but make sure we are in time for the vsync. So that's why we wait a little bit less to give this the chance to prepare the back buffer to be ready for presentation. And that's just it. We also lock the swap chain because we don't want it to conflict with things like resizing, which is going to discard the old image, the back buffer that we are currently using. And that's just it. We also improved the samples, and we added the pressure sensitivity for the Wacom wind tub drivers. And let's get on trying it. So this is it, and here what it looks like to be drawing on the new Vulkan canvas, right? Whoops, we are still hitting some weird conflict. So during the presentation something else happened. And what did actually happen? We need to go to the threads, and while the presentation thread was working on presenting, this one was just waiting. The canvas thread was just waiting, and this should just be waiting on the swap chain mutex. Nothing really seems to happen here. Wait until idle. And maybe we cannot call this function. Wait until idle. What? Wait until idle. Needs to synchronize all the cues that the device created. That is kind of tricky. So one cannot just call VK idle, right? We may not even need it, because we are only interested into the swap chain there. Yeah, not really. I mean, if we go down here and on resizing, this is going to use the screen command, but when we lock the swap chain, we also wait for the fence Chronos present. Do we have a presentation fence? We should have a presentation fence. Render finished semaphore. So we only have a semaphore. That's the swap chain. Well, when the presentation is finished, that also means that it has done its work, so there's no need to have any fans waiting on it. And that's why we should be good, because at that point the device has completed the task. For what matters regarding to the swap chain images and also the rendering of this queue, and so the to-screen command should be good. That's why we can go ahead and create them, because we have acquired that swap chain mutex. Well, that was too optimistic. What is still going on? The queue. So it still complains about the queue presentation. And let's see if we get any useful message from here. No, we don't. It is competing with what? Create swap chain. So we are in create swap chain, which is doing nothing but waiting. Well, we are using the surface, so that's why what it is complaining about. Let's try to move the locking up in here and see if that is the reason. And that is not. So there must be something else on the queue presentation. Out of date. So that's the queue present. What is out of date? And who is presenting it? Okay, so here we are. Is it incompatible? No, it's out of date. So out of date what? What is out of date? Queue present. Is it the queue or whatever? So there is something out of date. There is something out of date, and that might be so lock here, create the swap chain. on resize, create swap chain, and that is still here waiting. So this is waiting, but that is waiting, but maybe it's got invalidated before. I mean, during the presentation, waiting for the surface that got invalidated because of the resizing. And so at this point, I think we should be able to just move on. It should not be a deadly exception. Let's try trying. So what if we try and catch? How do we even catch things in Vulkan C++? Let's see. So pp present system error. Is that something? Let's see. VK system error. Error category, is that the only exception? Logic error or just error? I don't know. What? Okay. Can we do this? Okay. That's good. It works as expected, so it wasn't really an error. It's just an exception that may happen because while we are resizing, Windows resizes the surface before notifying it to the system, and at that time we may already be in a presentation state, and there's no escape from that except an exception. That's why we need to catch that and behave accordingly. So exceptions like this are okay. So we are good, right? We can now paint us on this lovely surface, although we are hitting some limits of the number of samples that we can draw at the time. At any given time. What? All right, let me check something. Set stylus. New packet, set stylus, handle message. Initialize, button up, down, reset pressure. So that's what I forgot. Up, let's go to the message loop and mouse button up, reset the pressure. Because otherwise we get 0 when using the mouse, when switching from the stylus to the mouse. And yet still 0. Oh, that was because it was still loading. So I get something and then we can draw again. Okay, anyway. it's pretty good. Just a reminder that this is an 8K canvas image, right? There is a freaking high resolution image behind. Let me switch to release. And also I am getting kind of sick of that green. Well, blue over green, so we want to change that background to a solid white. And also change the color of the stroke. Canvas render thread to a nice black. And let's run that again. Cool. Nice. That is a very lovely canvas. And these strokes. Something happened because they are getting slower again. It used to be much more responsive, so it might have to do with some of the changes to fix the swap chain. Be back in a bit. All right, back again. Yeah, so 8K, let me bring that beast down to 10 what 2048 by 2048 because I want to save that to a file. Yeah, right. There was this issue where we are back to the ugly delay. Let's see if that's a matter of that line, which actually is. And why is that? So if we already waited, then we return false. to the render thread, main render thread, which then does not increase, and also does what? Nothing. Really just goes back to call this function again, and I'm not quite sure why this happens. Okay, let's try to remove like the whole optimization, and what? Something's wrong now. What? Q submit. So apparently it cannot submit because this is still a command buffer, render stroke. This is creating the commands, and this is doing some stuff on the surface. Let's see if that just happened for no reason, which did. Okay, so this is the amount of space, which is obviously really high. We don't want anything like that. But as soon as we go back to the render frame function and add this weight, I mean it's slip, it's not a weight, nothing really improved much, which is kind of disappointing. And that comes all over here. But if we instead return that we did not render the frame, it gets a real boost for some unknown reason. And why does it do that is completely out of my mind. Because if we just return dt. But maybe it's not about the sleep. Let's see. Wow, this sticks so well. And it's not about the clear. It's not about the weight, but this way we are busy waiting on that thread, which is not good. And so why is this not working properly? Sleep 4. Let's try to remove the small window. And that still works nicely. It's super compact. It's very sticky to the cursor. So let's say we will just rely on this to be super fast. Okay. And it really is. That's super cool. Now let's hit S to save. S should be saving the output, hopefully. Let's see. Let me jump right to the key up, and it's not C, but it's space. So let's try that again, and space should freeze it for a second and save. The output to an HDR. Let's see if we can have a look at it, and it's pretty nice. Let me open that in Photoshop. And it is super clean. We don't even see the single strokes anymore. And at this point we want to play around with Photoshop and the same brush potentially. So how do we pick a new brush in here? brush image that I'm currently using. I can't seem to find it anymore. Come on. Oh, here, no, not the Vulkan logo. Where the hell did that end up? Oh, here it is. Brush. Why couldn't see it? Here is the brush, and I want to edit, define a brush preset, brush.png. That's the brush. Let me set the size. It looks about the same. Then let's pick the same color and bring that flow down quite a bit. What? Come on, what the hell? Dude. Okay. Yeah. We're getting there. I mean, that looks quite neat. Might be 10%. Yes, it's exactly 10%. Even though we are seeing some repetition here in Photoshop. So let's bring that spacing down and that flow back again. Might be something like 2% maybe. Yes, maybe 3%. Yeah, we are there. And that looks pretty similar. Okay. Okay, so how is the performance then? Pretty good. Well, kind of. Well, Vulkan is definitely working better, but it's not enough. Let's try to stress test on the performance again. By jumping back to 8K. Go for it. And again from here. Press save. This is going to take a little longer because it's 8K now. Hopefully it will make it at some point. And unfortunately it is saving in a single thread. Okay, it made it. There was quite a jump. It took almost 1 GB to save that image. And how big it is? 30 megabytes. Not bad. Let's reopen that. And here we are back. Well, performance-wise, what the hell? We are doing pretty great. Let's see. But this is the fastest we can draw in Photoshop, right? But with Vulkan, wow, that's quite some lag. And hey Vulkan, wow, that's it. I mean, yo baby, that's nice. And I can only imagine what happens if I get that a little bigger. Wow, that's a snake, a very slow snake. Okay, enough playing around. Should probably move to the main topic for today, which I haven't even started yet, which was multi-sampling. And that matters because if we go, what the hell is that number? 1K, we might start to see some really nasty artifacts. Maybe not at this level, but size, canvas render thread. Here, what about multiplying by the pressure and maybe get that pressure back to be a simple constant pressure to 1.0. Okay, it gets too big. We want to focus on smaller scale. Okay, that's the thing that I want to avoid. So this very ugliness that comes out of a smaller brush. Yeah, that's pretty ugly, isn't it? But Photoshop doesn't seem to be handling that any better, actually. I mean, not really. It is getting a little bit nicer, and you can see there is probably some sort of anti-aliasing. But there is not enough hardness on this brush. Okay, it is better now. Very hard. And very aliased, whatever. So let's save this and open it back in here. It's really bad. Right, we want something like this. How about 0%? No, cannot do that. Why is it not dark enough? I mean, maybe we need something. Wait. Ah, dude, so annoying. Even this is not dark enough. How does anyone get something really dark? Might just be because of the number of draws per pixel. If we get that down to 1 per pixel, we might even get the same result. No, not really. And why we don't is because pressure, brush value, and then mix that back in. Why does it get so dark? Man. Why is it so dark? Maybe because there are too many of them. And why is that? Like samples count, right? We get the number of samples, which is the distance, and that distance let's see if I can divide that by 10. Okay, so the thing is that it is actually quite dark, and that is because the blending is not the right one yet. So that's why it is getting this dark. The blending just weights the average of the two colors, while it should instead use the flow, which means that it must be weighted to the complementary of the current alpha or whatever. Anyway, means that we are now bound to move to multisample stuff, otherwise the title is completely wrong. And so that is what we are going to do right now. Right after submitting these changes, later please, pressure, shader utils, Win tab, logging stuff, Wacom stuff. Okay. Cool. So implement Wacom and stylus pressure. With Wacom Win tab drivers. Cool. And that's it for now. We start clean. We start clean and we jump straight on multi-sampling. Let's see if this makes it simpler. Interlacing, blah blah blah. Okay, so how do we do that? Limits, right? What are the limits? Yeah, max usable counts. Phase data. I'm gonna physical device properties. Setting up a render target. Create. We'll just get the number of samples. Optimal. Image color use, figure norm per device, transient attachment. What that means? Transient attachment. Levels, sample count, B turning optimal, destination, VK image using usage sampled, Yes, it is. Adding new attachments, samples, one. That's just it, isn't it? Swap chain sample. Okay. Okay. How does someone use a multi-sampled image in a shader? Sampling from a multi-sampled image. Let's get back. Samples. Sample rate shading. Sample rate shading. What does that even mean? Okay. Samples count. Okay. Lazily allocated. Yeah. Swizzle. Multisampled. Depth. Sample count. The render pass. Attachment has these samples. That's swap chain. Set up frame buffer. Multi-sample target. Bind command buffers. Okay. Descriptor set. Image sampled textures. color map. What is the color map? Features multisample rate, emphasize with sample shading pipeline. Sample shading enables per sample shading to avoid shader aliasing and smooth on frequency texture maps. And mean sample shading, minimum fraction of sample shading. Sample rate shading. Rasterization samples. There is quite some stuff to initialize here. Shading. Okay, let's start from the initialization. Creation. Features. Device features. Sample rate shading. Okay, that's it. And with that enabled, we should already be good to go. Unless we don't have any device that supports that feature, which luckily we do. And now render target creation. Samples. Let's start with 4 samples, shall we? We want 4 samples. Mean sample shading, which is minimum fraction of sample shading, which means I have no idea, but let's do a 0.25. Authorization E4, sample shading enabled, is true. So at the image creation, that's just it. We might even be good at this point. And obviously we are hitting some error. So description binding index requires bound image to have VK, but got 4. So how to do that? The binding. Let's see. We get descriptor on the draw time. So that means here in the to screen. This is the image. Combined image sampler. Open image. That's the descriptor image, and here's the view. On the render target, how did we set the view? Create frame buffer, the view, image view creation, we got a swizzle, sample, create image view for the MSAA target, layer count. So there is not much to define regarding to the number of samples in the view. Come on, give me the help of this. Base MIP. Okay, there's not much about samples. So how does someone draw shader image layout? How does someone draw a multisampled image? Let's get back on that other tutorial, but this one only set it up for being used in the swap chain of the main window. Resolving multisample, right? Resolve image. What does that mean? To resolve a multisample image to non-multisample image. During resolve, the sample corresponding to each pixel location in the source are converted to a single sample before being written to the destination. When the server are floating point or normalized type, so we need to resolve let's see if I can save that anyway, which doesn't seem to work, but must be one sample. Source image must have a sample count of 1. Multisample shader. Okay, so I'm going to do as a mechanism until aliasing points technique is to sample in each storage for color depth. Apply to each same independently. The color sampled values can be later resolved to a single color. How to resolve it? Rasterization samples. So apparently I need to resolve the image. which makes it a little bit more complicated than I thought. Oh, wait. Great. No answers. Pixel fetch. So sampler 2D multi-sampled. Sampler. Maybe is the sampler. Which gets defined here. So we've got the sampler. Which in turns get created here. Let's see. Vulkan. The third, multi-sampling. Okay, sampler, sample position, resolve. What? Pixel fetch. What? Average resolved sample. So with the multi-sample need to be resolved manually. Why? With the pixel fetch. The number of samples. Okay, yeah, fair enough. for every sample. Shaders deferred multisamplings. And there must be an example about deferred multisampling. Let's see. Sample rate shading. Off-screen frame buffer. The number of samples. The various color attachments. Not format. Okay. Dependencies. Okay, here's something new. VK sampler address mode. Sampler address mode. Sampler map. Create sampler to sample from the color attachments. Maps. Clamp to edge. Map. Why? Why does it need a mapped? Okay, these are just a simple combined image samplers. So there's nothing special about it. Which in this case brings us to the fragment shader. Boom. Cannot be size, no matching overload. Texture size does not work like that. So in GLSL, texture size. It should work on multisampled. Sampler 2D MS. What's wrong? No matching overload found. Because there's no load, a loadee. oops, not what I meant. And at this point, texture no matching, there's no texture, but there is a texel fetch. Texel fetch. Texel fetch at sample 0. Texel fetch, no overloading found. Let's see. Texel fetch and UV is IVEC2. What is GL frag? It's a VEC4. Okay, which makes sense. IVEC2 should do the trick. And what is the problem now? We've got the RGB, can temp, 2 component vector float, 2 component int. Where? Int. I mean, IVEC2. Okay. I'm not getting anything. The descriptor binding. So where is the problem now? The problem now is in the other function, I guess. Is it the fill? Texel fetch. On tags. F tags multiplied by vec2 of texture size of tags, all casted to IVEC2. And we gonna get the sample 0. All right, this is a multi-sampled image. Okay. That we still need to resolve. And in order to do that, we are just going to copy and paste. Spaces, please. Okay. Number of samples, which is 4. Right. Cool. At this point, we want to resolve that. And let's copy this over the other fragment shader. Well, actually, this should be good enough. And here, again, we want to resolve that samples now compiles everything. Resolve. Yep. Let's try again. This works. And this one also compiles. Okay, this is a multi-sampled drawing, which is definitely better than what it was previously, given that we are drawing at a 1K image, which is pretty low. Can we make this parametric? Yeah, maybe in the next stream. But now, what happened to the pressure? Okay. little more. It's not super clean though. And I'm not seeing a great blending. Let's see if that can be improved. Yeah, it is still in blending, which is nice. But now there is something else. It is no longer it's no longer interpolating correctly the image. And that's something that we need to fix. But so far it's been quite nice. And we've got the multi-sample enabled. It is drawing using multiple samples. Let's see. I can probably increase the number of samples. Somewhere. I can increase the number of samples. I should make it possible to disable or enable that feature. And yeah, that's it. So that is something that I might do in the next stream. So it is good for now, and see you in the next sample. In the next sample, what? In the next stream. Bye.